Oh, ingat. Saya ingat. Nakas.
Itu. Good afternoon to one and all. So this is the first class I'm taking for B.Sc third semester. The syllabus for the third semester for chemistry syllabus is the solvents, which is I'm going to handle this semester for you people is solvents. So solvents. So here, what we need to understand first is that, so as I told you that I'm going to handle solvents topic for your third semester class. So before going to address about the solvents topic, we need to have some idea that what all concept we are going to learn in this solvents classes. So first of all, if you really have the syllabus of your B.Sc third semester, the topics followed or the syllabus is mainly is of like, let me tell you. So here we are going to study the types of solvents, then we are going to study the properties of good solvents, then we are going to study the non-aqueous solvents. Again in that we are going to study some of the characteristic properties of liquid ammonia, then liquid hydrogen fluoride. Then we are going to study some acid-base redox reactions. Then finally, we are going to deal with the water as a universal solvent as well as leveling effect. So this is overall topic, overall syllabus in this semester. We are going to deal with this special subheadings. So in that one, now let us talk what exactly solvent is. Why? What is the importance of solvent? Why one should talk about solvent? This is the question which is really arises when you are going to talk something about some topic, right? Especially in chemistry. So all the reaction which you are going to carry out in the laboratory. So without solvent, we are not going to do anything. Take anything which is in presence of solid only, we are going to perform all the reactions. Not only in chemical synthesis, take your own body. Say for example, all the ions, all the proteins which are present in the human body, they are going to dissolve in the water. As you know that, as you all know aware about the human body is consists of 70% of water. So this indicates what means water as acts as a solvent. Then what is solvent? Solvent is nothing but which is having the capability to dissolve the material or the solute and it make it as a solution. So now we got to know what exactly solvent means. So if you really want to see the like property of a solvent is that a solvent is a substance that dissolves solute resulting in the formation of a solution. So here we need to understand three keywords. One is solvent, one is solute, and another is the solution. So solute is the substance which is going to dissolve in the solvent and it forms as a solution. Simple example I can give you. Take a sugar, put it into the water, make it as a solution. So this clearly gives an idea. Solvent means solvent is the water, solute is the your sugar particles, and when we are going to mix together, it is going to form as a solution. So now we have a clear idea about what is solvent and why one has to study the solvent, right? Okay. So next question arises that why one should study the solvent and what are the types might be present in the solvent. So as you know, that solvent is nothing but which is there in the liquid form itself. Again, in that we are going to study the aqueous solvents as well as non-aqueous solvents. So the question arises now: solvent already solvent like in the liquid form. Again, aqueous, non-aqueous. Aqueous means containing the water molecule, and the one which is not containing the water molecule, that is non-aqueous. Example, we are going to say some of the, if you are going to call, if you are going to say any of the chemicals, say for example, dry ether, dry DMF. So as you know that if you take ethanol, we are not going to call it as a dry ethanol. Of course, we can call it dry ethanol, but we are not going to call it as a dry ethanol because ethanol contains water molecules. If any solvent is not having the water droplets or water molecule, so that time we can call it as a dry so and so. If the solvent containing the water molecule, so that time we are not going to say dry the water. Hope you have a clear idea now. That is aqueous solvents. Then non-aqueous solvents. Clear? Yeah. So now we studied about the aqueous solvent. Aqueous solvent is nothing but the solvents containing the water molecules is called aqueous solvents, and one is the doesn't contain the water molecule, that is called as a non-aqueous solvents. Now we have a clear idea of the both the concept, aqueous as well as non-aqueous. Now we'll take up another part of this solvent. One is ionizing solvents, and another one is non-ionizing solvents. Oh, this feel something like ionizing as well as non-ionizing. These words are, seems pretty different, right? Different in the sense quite interesting. What it might be, what it might be indicates ionizing as well as non-ionizing. Example, I can give some of the examples for this ionizing as well as non-ionizing solvents. Ionization means, as you already know, so far you are in B.Sc. third semester, you are already knowing in the first semester we are going to study ionization, especially in coordination chemistry, you are going to study ionizable phenomenon of the metal like your complexes, right? Yeah. Now come to the point. Ionizing solvents. What exactly is ionizing solvents? Ionizing solvents states that the solvents undergo autoionization. If the solvents undergo autoionization, if the solvents, wait for a while, if the solvent undergo self-ionization or autoionization is called ionizing solvents. So what is this ionizing solvents? I will give some examples. So first we need to understand ionization is nothing but as soon as we put the solute or something into the solvent, it has to get ionized, it has to depart, it has to separate from one another. So for that kind of molecules, we are going to consider as ionizing solvents. Take the examples. If you take the water molecules, as you know that H2O plus, if you take the two water molecules, what happens? It is going to form as a hydronium H2O plus as well as H plus. Okay. So now this clearly shows that when we take the water molecules, when we mix it with each other, it is going to away from, like no separates. Means that auto-ionizes itself and going to form as a hydronium ion as well as proton. So this is an example for the ionizing solvents. I can give one more example. We take any of the solvents like ammonia. We take two molecules of ammonia. It will use as NH4 plus, that is mine, plus NH2 minus mine. See, this is also an example for the ionizable solvents. So now, so far we studied what is ionizing, what is the solvent, and what is aqueous solvent, what is non-aqueous solvent, and what is ionizing solvent. So now let us see what is non-ionizing solvents. So it is very simple. It is exactly reverse to the ionizing solvents. Means the solvent which do not undergo autoionization. The solvent which do not undergo autoionization. Auto means self. Autoionization. They do not ionize at all and are called as the non-ionizing solvent. I can give some examples. Example benzene, as well as take any of the organic solvents. Benzene, then your hexane, then petroleum ether, then carbon tetrachloride, carbon tetrachloride. So all these are nothing but the organic molecules, organic solvents. So as you know that in the organic solvents, the polarity is very less. Polarity is nothing but separation of charges. So the molecules, like especially in your organic solvents, what happens, there is a share of electrons in the covalent nature. Covalently, throughout the molecule, the electrons are dispersed in a covalent manner. So hence, what happens? There is no separation of charges takes place. Separation of charges in the sense the two electronegativities of the atoms, not like very large. When the two atoms electronegativity is very smaller in difference, so that time we cannot expect any of the polarity. I can give example. We take H2. Example I am giving. Okay. So this is highly polar in nature. I can call it as a highly polar in nature. Again, I can give one more acid. So this is HL. I'm giving example for this one. This is hydrochloric acid is a gas, but I'm giving the example for what is polarity or polar in nature. So as we know that oxygen and hydrogen. If you take this one, oxygen as well as hydrogen, oxygen, as you know that the atomic number of oxygen is 8. If you really write the electronic configuration of the oxygen, it would be like S2 would be 2, then 3s2. Yeah. First shell, second shell, and third shell. Here, oxygen is having the ability to accept the electron. If you see the outermost electron, this is 1s1. So this one electron can easily donate to the oxygen. So this indicates what? Oxygen is having the ability to accept the electron, and hydrogen is able to easily donate the electron. So when such kind of atmosphere we can observe, so that time we can say polarity. So by taking this HCl, if you take hydrogen and chlorine, chlorine is having more electronegativity than the hydrogen, so that's why we can easily find the polar nature. Okay, counterpart. So this non-ionizing solvents, especially all the organic solvents, acts as a non-ionizing solvents. Here we are not going to see any of the polarity in the molecules. That's why they are classified as a non-ionizing solvents. So far we have studied that solvents, what exactly is a solvent, then what are the types of like aqueous solvents as well as non-aqueous solvents. Then again we have studied the classification of solvents, that is ionizing solvents as well as non-ionizing solvents. Okay, so this is brief introduction about the solvent. So since from your take your human body itself or the human body itself contains the lot of amount of water, that is solvent, which is having the ability to dissolve almost all ions as well as proteins within it and possessing as a universal solvent. So now one can easily understand what is the role of solvent, especially this solvent. If we talk about beyond this, not beyond the syllabus, but within the, if you talk about the chemistry terminology, as you are aware about your chromatography, as you all people have studied in your PUC itself, it seems chromatography, especially high performance liquid chromatography. If not, you take simple thin layer chromatography or paper chromatography. So we all have done the experiment that we are going to take the in the beaker. If you take the paper chromatography, what happens? Like we are going to take the beaker and we are going to put some appropriate solvents. Then we are going to keep the strip. That strip is nothing but the made of your silica substrate or thin aluminum foil. Upon the silica is coated upon the your this aluminum foil. So where the solute, which is to be separated, will be placed, will be dotted, or will be spotted on the your silica substrate in the form of very in a dot nature. We are going to place this one inside the beaker. Then what happens? The solvent, which is going to react with this solute, then it moves from the bottom line to the upper direction. When moving, what happens? We can find the separation of the analytes. So there only you have studied the solvent. All solvents will not contact or react with the solute and makes them to get depart or makes them to like separate from one another. It all depends on the nature of the solvent. Like this, like this. In organic chemistry also, so far what we are going to study in our laboratory classes. So solvents really plays an important role to form any of them to catalyze the reaction. Say for example, I will be taking sugar and I will put it into the honey. So that time what happens? So that time we can see that there is nothing change. Nothing change is nothing but the sugar is not going to dissolve in the honey. So this indicates what honey is we are going to consider as a organic solvents, kind of organic solvent, which is not having a higher polarity nature. That's why it is not going to make the solution using the sugar. If I take the sugar into the water, then what happens? The water is having the ability to dissolve the sugar, so thereby we are going to see a clear solution containing the both solute as well as solvent. So like this, solvent plays an important role in synthesis of the various organic molecules also. Not only organic molecules, you take any complex also. So this thing, like the importance of the solvents in laboratory, we are going to feel, or we are going to we are going to visualize the role of solvents in the laboratories classes. But before that, we should have some basic idea what exactly is solvent, what are the types of solvents, and how exactly the solvent acts as like that. Okay, this is all about solvent, aqueous, non-aqueous, ionizing as well as non-ionizing solvent. Now, let us see. Then, we'll see the types of the our solvents. So, based on the Bronsted-Lowry concept, the solvents are classified into acidic solvents, basic solvents, amphoteric solvents, protic or aprotic solvents. These are the four types of solvents we have generalized or we have categorized based on the brown stability table. Now let us see what exactly this acidic solvent is says that. The first one is, as we talk about, if we talk about the types of solvents, first one is acidic solvents. Next one is basic solvents. Third one is amphoteric solvent. And the fourth one is, and the final one is protic or aprotic solvent. Okay, so these are the types of solvents. Based on the most theory, we have categorized, classified the solvents. In that first one, we see what exactly this acidic solvent says. The question arises: what exactly might be the acidic solvents, right? So, as you all studied acid bases in your previous semester, of course, it's a very generalized since from your school days. Probably you might have studied what is acid, what is base. So, in general, if I want to say, for instance, like acid is nothing but having the, like base is the substance which is having the ability to abstract the proton. Acid is the one which is readily donate the electrons. Like this, so-called we have studied in the previous classes. In a similar way, let us talk about what exactly acidic solvent. See, acidic solvents is nothing but these solvents have a strong tendency. These solvents these solvents have a strong tendency have a strong tendency to donate protons, to donate protons. See, we now should give importance on the word which has circle. We are talking about the protons, acids. So there are, as you know, that two concepts are there in the acid-base reactions or acid-base. We are going to categorize. One is Lowry-Bronsted, this one, and another is Lewis acid. That concept, right? Lewis acid. One is Lewis concept is there, another is the Lowry-Bronsted theory is there. So when to use these two concepts? This question arises as being organic chemist, as a being a chemist, we should know when to use these two terminologies. The Lewis acid-base theory, especially we are talking about the electrons, and the Lowry-Bronsted theory, especially deal upon the protons. So now one can understand where protons can come, where electron can come. Especially in inorganic chemistry, say for example, your coordination chemistry is full of electrons. It's full of electrons. This metal will be having this much oxidation state, and this ligand will donate the electrons so that it is going to get bind with each other. So thereby we are going to form as a complex. Simple example I can give for complexes. You take any of your tetrastic acid as well as in terms of zinc tetrastic acid that is going to form as a gelatin like a complex. So here zinc has in the +2 oxidation state. So EDTA, ethylene diamine tetrastic acid, acts as a ligand that donates electrons to the zinc. Say for example, if the ligands are there, then here metal is there, any metal. So metal usually having the oxidation state is +2. So this plus 2 gets satisfied by the electrons which is present neighboring to this metal ion, that is acts as a ligand. This ligand will donate the electrons to the metal ion, so thereby it's going to form as a complex. So this is what we are going to study in the inorganic so-called your complexes, coordination chemistry, and give the example, coordination chemistry. So that time we are going to talk about electrons. If you really talk about the protons, that comes in the organic part, organic section especially, we are going to deal with the protons. So that's why we are given name as a Lowry-Bronsted concept or Bronsted-Lowry concept. So now let us see what exactly this acidic solvent means. So as I told that these are the solvents have a strong tendency to donate protons. The solvents which is having a strong tendency to donate protons, we can call it as simply as an acidic solvent. So I can give an example for this acidic solvent is H2SO4, that is sulfuric acid. And another example I can give you is acetic acid. Of course, though it is not a strong acid, though it is acetic acid is a strong acid, but it is having a tendency to donate protons. So that's why we are going to call it as a acidic solvent. Now the question arises, which atom of this molecule donate the protons? Question is very simple. Here in the acetic acid we are observing the presence of the H here. So this forms as the acetate CH3 COO minus then H plus. See, this H plus has been generated or liberated or we can observe from this acetic acid, and this proton is ready to donate or readily available in this solvent. Means this is having ability to donate the protons as it is can. So this acts as a strong acidic solvent, or I can call it as an acidic solvent. So the name itself or the statement tells that these solvents have a tendency to donate protons, strong tendency to donate protons. We can call it as an acidic solvent. Example is acetic acid as well as H2SO4. So before going to write any of the molecules, one should know the exact structure, because this orientation also plays an important role. Okay, this orientation we are going to study, with some of the classes, but one, if you really have an idea about the structure of any of the molecules, that would really be good for understanding or to appreciate the subject. Example I can give you. So water is in bend shape. So question arises, why water is in bend shape? Simple question arises. Then again, if I talk about the ammonia, of course this ammonia you are going to study in the further classes of the same solvent topic only. Ammonia, if I write about ammonia usually appears in the form of like tetrahedral. Again, if I take ammonia, then again boron trifluoride. Again boron trifluoride. Yeah, now we should have a clear idea about why we have written this water molecule in this bent form and this ammonia is in pyramidal shape, and why not we have written boron fluoride in the trigonal planar. Of course, we should have a clear idea about this BF3. Later we will discuss this one. Now, simple example I will give you about water molecule. Why this water molecule is in bend shape? Why not straight? Why not in 90 degree? It could be like hydrogen, oxygen, hydrogen, or it could be like straight oxygen, hydrogen, hydrogen, or it could be like in some other shape. But this water molecule is existing in this form, that is in bend form. Question arises, It is very simple. As we know that oxygen is having two lone pair of electrons here as well as here, two lone pair of electrons. These two lone pair of electrons will interact with the bonded pair of electrons. This bonded pair, the electrons which has been binded, one electron from this side and another electron from this one. This is the bonded electron. This is the unbonded or not bonded electrons. Interact with each other. Interact with each other. When the interaction takes place among the bonded pair of electrons as well as non-bonded pair of electrons, there is a repulsion takes place. Repulsion, as you all know that, when the repulsion takes place, when the repulsion takes place, when the repulsion takes place, this hydrogen molecule comes this side and this hydrogen molecule goes this side. So that's why this water molecule exists in the bent shape. This plays an important role. Stereochemistry. So this is another section. We'll talk about it in the further classes. Stereochemistry. So if I take any of the solvents, I'm going to take some of the molecules like to react with this molecule. So that time I should see whether the incoming group will be added to this water molecule from the top side or from the bottom side. This is generally we are going to call it as a stereochemistry. So this is, of course, this is not a to be discussed in this solid topic, but you should have an idea why the importance of structure of the organic molecules is very important in determining the rate of reaction, like that. So as you know that, come to this original concept of this solvent, that is acidic solvent. So acidic solvents are nothing but the strong tendency to donate protons. Example, like I have given H2SO4 as well as acetic acid. So here, there we can find the presence of hydrogen as well as the, in both the cases, sulfuric acid as well as acetic acid, we are going to find the protons. So that protons can easily donate. So that's why we are going to name or categorize under the acidic solvents. Yeah. Now, let us talk about the basic solvent. Okay, we have studied acidic solvent. Oh, the presence of hydrogen that will be donated easily, and we are going to collect as an acidic solvent. Right? Okay. So that is about acidic. And what is basic solvent? So as you know that, again, I am talking in terms of the protons. If I will talk about the Lewis acid base theory, I will talk about the electrons. But now I am not using the electrons. I am talking in terms of the protons. So now let us see what is exactly this basic solvents. These are the solvents. Basic solvents. So if I talk about the basic solvents, these are the solvents. These are the solvents having a strong tendency, having a strong tendency to accept proton, See, now we should do a clear highlight about the accept as well as donate. The one solvent which is having a strong ability to donate electron, that is called acidic solvent. And the solvents which is having a strong tendency to accept the proton is called the basic solvent. Right? Let us give some examples. Example I can give here, pyridine. As well as you can take one more example, that is ammonia. I can give this example as having the ability to accept the proton. So for example, I have shown you the structure of ammonia is in a middle, pyramidal shape. where one low pair of electrons is available upon the nitrogen atom. So that can be taken up, given to the proton, and then it can easily accept the proton. So that's why we are going to categorize it under the basic solvent. Hope clear all the topics which I talk about now about the acidic as well as basic is clear for you people now. So again, another part is there about your acidic is over, basic is over. Another is amphoteric solvent. Third one is amphoteric. Amphoteric solvents. What is this amphoteric solvents? The question arises. So far we have studied acidic solvent, we have studied the basic solvent. Now it is amphoteric. So this is exactly the in between the acidic as well as the like a basic solvents. So these are the solvents these are the solvents behave neither a strong tendency neither a strong tendency to donate or accept the proton. To donate or accept the proton. Clear? So this is C. Either it can donate the proton or it can accept the protons. If it is going to donate very strongly the proton, that is acidic. If it accepts the proton, that is basic. Or neither, having the partial character, depending upon the situation, depending upon the condition of the atmosphere of this reaction. This solvent acts as a both. That time we are going to call it as a amphoteric solvent. I can give water as the best example for this amphoteric solvent, right? Okay. So then another type of solvents that is the categorized under these lowly said solvent category. So that is protic or aprotic solvent. Now first see what do you mean by protic solvent? Protic solvent. No, see this protic solvent. These solvents contain hydrogen and from which proton can be derived. Means these solvents contain hydrogen from which protons can be derived. Means here question may arise. What exactly the meaning of protic solvent? See, in protic solvents we can find the presence of the acidic protons, or we can see the protons. That is, we are going to call it as a protic solvent. Example, I can give any of the acids which is having the protons. You take the example of your hydrogen cyanide, then hydrogen fluoride. Of course, why not? Water itself is a protic solvent because we are going to be able to find the presence of hydrogen, right? So, under the category of protic solvents, water comes as a protic solvent, hydrogen fluoride comes as a protic solvent, then hydrogen cyanide comes as a protic solvent. Because in all these solvents, we are able to see or we are able to find the presence of hydrogen. See, hydrogens. So now clearly we can say protic solvents are nothing but the solvents which are containing the hydrogen. We can call it as a protic solvent. Clear? Yes. Now another category. There are some numerous n number of solvents we can find containing the both hydrogen as well as the non-hydrogen. Now we can call the one which is not having hydrogen, we can call it as a aprotic solvents. Like aprotic solvents. So protic solvent means contain hydrogen from which the solid hydro like proton can be derived. But in aprotic solvents, this is if we talk about the protic as well as if we talk about the aprotic solvent. Aprotic solvent. From these solvents, aprotic solvents, this is a single word. You should remember, aprotic is not aprotic. Aprotic, aprotic solvents are those. Aprotic solvents are those from which, from which, from which, from which protons are not, protons are not, protons are not ordinarily obtained, ordinarily obtained. So now you have understood. Like the aprotic solvents, in the aprotic solvents, we are not able to find the presence of protons. So in general, I can call this as a aprotic solvents will not be containing the protons. You take any of the examples of organic solvents. Example, your carbon tetrachloride. Then you take DMSO, dimethyl sulfoxide. Okay. Then you take trichloromethane, CH2. Okay. Again, you take one more example, that is best organic solvent, that is benzene. So these all we can classify under the category of aprotic solvents. Clear? So far we are studying the importance of solvent. Take from human body. Within our human body itself, we are having a lot of solvent, like 70% of the water is contained in the human body. Majority of the ions, proteins are going to get dispersed, dissolved in the body. So hope you can imagine the importance of solvent, right? So once if you understand what exactly the solvent, again we have studied the classified the solvents, like in terms of like uh, your classifications of ionizing solvent, what is ionizing solvent, what is non-ionizing solvent. Then again we talked about the Bronsted theory of your classified this one what classification of the solvent, under which we have studied the acidic solvent, basic solvent, then amphoteric solvent, then finally we have studied the protic as well as the aprotic solvent. Clear? So now in today's class we'll wind up with this concept. In the next class we'll talk about what are the good solvents should have a properties. If I want to call this is a solvent, what property should I have, or that solvent should possess? Right? If you take any of the examples in your classroom, there are plenty of students will be there. We are going to give some specific numbers, right? Register number, in order to identify, in order to call, like for clarity purpose, right? In that way, in a similar way, we are going to give, or we are going to like categorized. We are going to give some of the properties to the solvents. Such properties, based on such properties, if that obeys, that time we can call it as it is a solvent like that. Clear? So this is all about the solvent that we studied in today's class. In the further class, we'll talk about the what are the solvents should have properties of good solvents, and we'll, subsequently we'll talk about the water as a universal solvent, as well as the leveling effect. What exactly is leveling effect? And some of the subheadings of this solvent chapter will be discussed in the further class. If you really have any doubts, you can share with the groups. Thank you. Any class?